All right, so week 2, 31-1, Radian, what is it? First day of kind of this new unit, this Radian circle, trig unit, unit circle, all of that fun stuff. It's actually a really fun unit. I think it's more fun. It's a little less rigorous, a little less work than the past units, but it's more conceptual. So hopefully these videos start to break down what we're looking at and you know, where this kind of stuff comes from. If you've heard some of these, like trigonometry, we've heard a lot, but we haven't really talked about where it comes from. The same thing with pi, right? What is pi? That's one of our biggest questions today. What is pi? You can see it down here. What is pi? To answer that, we're going to figure out what a radian is first. So 3 learning targets. State what a radian is, the definition of a radian. Describe the relationship between a radian and pi, so how do those two mix, and then also start to get familiar with the introduction of the unit circle, which you see here. I've sent this out a little bit over the first break, the COVID break, but it didn't require it, right? So eventually we're going to have to learn to fill this out and learn to know what all of these blanks are, and hopefully this week that kind of you'll get more familiar with that and whatnot. All right, start here. What is a radian? We know pi is like 3.14, right? And that goes on forever. And we know that we've seen this before in circumference and area of a circle. So area of a circle is pi r squared. Circumference is 2 pi r. All right, r being the radius. So we know that. We know that a whole circle is equal to 360 degrees. And so I raised the question, why? Why is a circle 360 degrees? Who came up with that? Okay, well, it's kind of a tough question to ask. And there's actually a lot of conflicting views. The history behind it, there's a few different historical ideas of why 360. First off, one of the biggest historical ideas is that 360, and it seems easy, 360 is divisible by a lot of numbers. So 360 is divisible by 1, 2, 3, 4, 5, 6, not 7, but 8, 9, 10, and so on, right? So it's divisible by every number 1 through 10 besides 7, which is pretty convenient, right? So that's, what is that, 9 out of the 10 numbers, the first 10 numbers it's divisible by, which is incredible, right? You also can keep going, so it's, I think there is, I forgot the exact number, I think it's 32 divisors. I could be wrong on that, but I believe that there's 32 divisors. So that's a lot of numbers, right? It is nice to be able to divide a circle into a lot of different divisors, as opposed to, let's say, hypothetically, we said a circle was 100 degrees. All right, well, it's easy when we're going to cut it in 4, right? So this would be 25 degrees, this would be 25 degrees, this would be 25, and this would be 25, and that's easy for us. I'm talking about those central angles, by the way. That was a term in geometry, central angles. It's easy for us for that, all right? Well, that makes sense. What if it was 25 or 100 degrees, but we wanted to do it into thirds? Okay, so thirds would look like something like this. Well, then this would be 33.3333 ... so on, and this would be 33.33, and this would be 33.33, and that's just not, that's not okay, right? We divide the circle by 3 so often that dividing it in thirds, we want a whole number there. All right, whereas now if we do this as 360, we now have 120, 120, 120, right? So it's actually easier for us to divide by 3 and 4 and 2 and 5 and 6 and 8 and 9 and 10 pieces of that circle. So 360 is very helpful in that sense. So that's one idea. That's one historical idea of why 360. The other idea, which seems very obvious, is that we all know of a calendar being 365 days, right? So there's 365 days in the year, which is weirdly close to 360, if you think about it, right? There's the sun in the center of the solar system, and then we're here and we go around. It's more of an ellipse, but back when the Babylonians and all them, they were studying all of this, the Egyptians, they knew that the center, and then they thought it was a circle, so they would go 360 days, or 365 days, until you were back and the sun was in the same place. Now, they simplified this a little bit. They didn't want to use 365. Instead, they used 360. So there's ideas that we go with 360 because it represents the days in the year, quote unquote. Not in the calendar we use today, but way back when. And that is another idea. Maybe the 360 comes from the calendar. Again, we don't actually know. There is one more idea that actually has to do with the Babylonians. And the Babylonians said that they liked base 60. Everything was base 60. So for instance, they were the ones that said there are 60 seconds in a minute. Okay, so they're the ones that said there were 60 seconds in a minute because they like to divide things by 60. All right. They also liked hexagons. This is true. They really enjoyed hexagons. They really liked things that were sixes. So if you think about a hexagon, if you take 360 or a circle and make a hexagon out of it, let's see if I can do it. This is not perfect, but whatever. Okay, you put a hexagon in there. Well, there's 6 different triangles. Okay, 60 times 6 would be 360. So that's where that idea comes from. That maybe the Babylonians are the reason that we use 360 degrees. Again, these are all ideas. This has nothing to do with what we're talking about today, a little bit, but the history behind this random 360 degree angles that we see in circles. It's random, but it's random in the sense that we have history behind it. Mr. Keene would be proud that I just talked about history there for 8 minutes and 30 seconds. Okay. It would be much easier for everybody if we got away from the 360. And by easier, I mean more mathematically correct. Because we have something called a radian that may help us divide the circle. Not in 360, but it may help us divide the circle. Radian, here's our definition. Radian sounds a lot like the word radius. I'm going to put a big question mark there because that should kind of spark your interest. Radian and radius sound very similar. So the question becomes, okay, well, what is a radian? Here's our circle. Here's our radius. The radius will be in green. Now, my radian is essentially what happens if I take this circle, or this line, let's see if I can do it. Oh, maybe it won't let me. If I take this line, this green line, and I start here, and I wrap it around the circle like that. So, remember, we usually call this R for radius. This is the same length, this green spot right here is the same length as r. This is also 1 radian. Okay, so what is a radian? A radian is a radius length around the circumference. Okay, it is a radius length around the circumference. This is 1 radian. This is 1 radian right there. Okay. Now, let's keep going. This is 1 radian. What happens if I do another radian? Maybe like there. And these are all kind of estimates, but I could be more precise, but these are all kind of estimates. This would be 2 radians. 2r. All right. And then let's go one more time. Redo that line. This would be 3r. Not quite all the way around half the circle, Not quite the semicircle yet, right? What are we left with? That little bit. All right, so maybe you're thinking, maybe it's starting to get to you. This little bit, I'll give it to you, is 0. This little bit right here is 0.14r. So that little bit is 0.14r. So what is this whole thing total? If I start here, and I go all the way around the half circle, the semicircle, that's 1 radian, 2 radian, 3 radian, plus 0.41 radians, or the 0.14 radians. That's 3.14 r, or pi. So what is pi? Well, pi is the amount of radians around a semicircle or a half a circle. The amount of radians around a semicircle. Number of radians in a semicircle. Or half a circle, right? The amount of radians in a semicircle. Pi, 3.14